So now let us start solving the questions from data structure that has came in the GATE 2023. So let us see the first question. This question is from linked list that has came in the GATE 2023 paper. So let us read the question properly. Let SLLDL, what is the meaning of this? Singly linked list deletion operation. Let SLLDL be a function that deletes a node in a singly linked list given a pointer to the node and a pointer to the head of the list. What it is saying? It is saying that suppose this is a linked list containing various nodes. This is the head pointer. This node is pointing to this node is pointing to this, containing data and pointer. So now it is saying that SLLDL be a function that deletes in a node, that deletes in a singly linked list given a pointer to the node. Suppose a pointer to the node is given. Suppose there is one more node. This last one will point to null. So it is saying that given a pointer to the node, suppose you have to delete this node. So a pointer has been given. Suppose P is the pointer to this node and a pointer to the head of the list. This is the head of the list. So pointer to this is given. Similarly, let DLL be another function that deletes a node in a doubly linked list. What is doubly linked list? In the doubly linked list, we have two pointers. This pointer points to the next node and the previous pointer points to the previous node. This pointer points to the next node and the previous pointer points to the previous node. Similarly, this will point to this node and the previous will point to this node. So here it is saying that let n denote the number of nodes in each of the linked list. Okay, the total number of nodes are n. Which one of the following choices is true about the worst case time complexity of both of these functions? It means it is just simply asking if you have to delete a node, you have given a pointer to delete a node in a singly linked list. So in worst case, how much time it will take? And in case of doubly linked list, suppose you have to delete this pointer, the pointer is given and also the pointer to the head node is given. So how much time it will take to delete the node? So let us first take for the singly linked list. So if we have to delete this node, what should we do? What should we do? This pointer of the previous node should start pointing to this one and then automatically this node will be deleted, right? So to do this part, we should reach this node, right? When we will reach this node, then only we can do this function. But in single English, we can't directly go to the previous node, right? So what we have to do, we have to start from the head node. We have to move in the forward direction and we have to move to that node, which node is pointing to this P location, this P pointer, right? So whenever we will get a node which is pointing to this node having address P, we will stop and then we will take the address which is pointed by this P node and we will copy this value to this previous node. So now this node will start pointing to this node and this node will automatically delete it. But if you will see, we are moving from head to the node just previous to the node that we have to delete it. Okay, so it means in the singly linked list, it will take order of n time. But what about doubly linked list? Suppose if we have to delete this node, how we have to delete? It means this node will start pointing to this node, and also this node will start pointing the previous to this node. So now in doubly linked list, we can directly get the address of the previous node because this node is pointing to the previous node. So directly we will take the address of the previous node. We will go to the previous node and then we will change its value from this to this. We will copy this value from here and we will paste it here, and then it will start pointing to this node. Similarly, we will go to the front node. We will copy the value from here and we will paste it here. So it will start pointing to this previous node and this node will be deleted. So here in case of doubly linked list, you can see that we are not traversing from the head to the previous node. We can directly go from the node to delete. We can directly go from that node to the previous node and also to the ahead node. That's why it will take order of one time. So that's why the singly linked list deletion will take order of n time and doubly linked list deletion will take order of one time. So that's why the correct answer is option D. I hope this is clear to all of you. So this is the next question that has came in GATE 2023. So here a C code has been given and the output has been asked. So here if you see, a function has been given. In the function, a static variable x has been used. Okay. What do we know about the static variable? We know that the static variable is initialized only once, right? As it is stored in the data segment, so static variable is initialized only once. Now we know that the execution always starts from the main program, right? So let us see. Here it has been mentioned that int x comma y, x equals to, it has called the function funcp. Now the function has been called. Here static int x equals to 1. So x variable has the value 1. So the static, so this line will executed only once. So now it has been executed. So next time it will not executed anymore. So now we can remove this line. Now x plus plus means now this value will be incremented to 2 and then x will be returned. So now 2 will be returned from here and this 2 value will be assigned to this local x. So now this local x is having value 2. Now what is why this y is doing? Y is again calling this function funcp. So now if it will call this function, this line will not get executed because it execute only once. I have already mentioned. So directly this x plus plus will be done. X plus plus means 2 plus 1, 3. And then this 3 will be returned. So in the place of this funcp, the 3 will come. Plus x, what is the value of x? This x is here, this local variable, it is 2. So 3 plus 2, y will be 5. So this local y is having the value 5. Now what it is doing? It is printing the x plus y. X is 2 and y is 5. So 2 plus 5 equals to 7. So 7 will be printed. So the correct answer will be 7. Okay. I hope this is clear now to all of you. That has came in GATE 2023 from data structure, C and data structure. So this is the program that has been given. Okay. And what has been asked that which one of the following options represent the activation tree corresponding to the main function. So we have to draw the activation tree for this code that has been given. We know that always the execution starts from main program. So in the main program, the three functions are called F1, F2 and F3. This is not main, this is F1. This is F1, this is F2 and this is F3. So in the main function, we are calling three functions F1, F2 and F3. Okay. So how it will do? First, the F1 execution will be completed and then it will go to F2 and then it will go to F3. So if you have to draw the activation tree, main function, it will call first F1. When the F1 will be executed, then F2 and then F3. If here we will see F1, F1 is not doing anything, just returning 1. Okay. It is internally not calling any other function. Okay. Now, what about F2? So here one value is missing. The f2 is called with value of 2 because here you can see a parameter should be passed, right? X. So 2 has been passed here in the value of x. Here if you can see, this is f3. So now this f2 will first call f3, right? So f2 will first call f3 and then it is checking the condition if x is equal to 1. No, right now the x is equal to 2 because the condition is called with the value 2. So the else condition will be executed. What here it is doing? It is calling the function f2 with, this is a recursion, right? It is calling 2 into f2 of x is 2, 2 minus 1, 1. So again it is calling the f2 function. Here the 3 is not parameter, the f3 is the name of the function f3 and f2 is called, earlier it has been called with the value of 2, now it has been called with the value of 1, right? Now again when it has been called, it will call the function f3. This f3 has been executed. Now again condition will be if x equal to 1, true. Now the x value is 1. It will call f1 function. Now here if you will see, the f1 is not calling anything and also the f3 is not calling anything. So this is the final activation tree for the given code. If you will see from the options, the option A is correct. This is the correct activation tree for the given code. Okay. I hope it's clear to all of you. This is the next question that has came in GATE 2023 from programming and data structure. So just read the question properly. What it has been given, a structure has been given. The node has been defined that each node will contain a left pointer and a right pointer and will also contain some value, right? So each node will have a left pointer, will have a right pointer and will also have some value. Now a function has been executed whose name is foo. Now this code has been given. Now the question is saying when foo is called with a pointer to the root node. So this is the root node of the tree. So this, the pointer, the address of this root node has been passed to the function foo. Now it is asking that what this function will print. Okay. So just try to read the function, what it is trying to do. Okay. When you will understand the question properly, then it will be very easy for you to give the answer. Just see what it is doing. It is saying that if p is equal to null, means whatever the pointer that has been passed to this function, if its value is null, then it will return 0. Otherwise, what it will do? It will take its value part plus the value that has been written by the left child plus the value that has been written by the right child. It will sum all of those values and then it will print it, right? So let us make this tree first. 10, 5, 11, 3, 8, 13. 10, 5, 11, then 3, then 8, and then you can see 30. Okay. Always remember recursion is very important for GATE exam. Always. Okay. So here if you see what this function foo is doing, this pointer has been passed and what it has to return? It has to return whatever the value this left child is returning plus its own value plus whatever the value that is returning by the right child. So to get the value from the left child, first this left part will be executed. So what will happen? Its left part will be executed first. It will return some value. Then right part will return some value, and then only it will be able to return the main value to the node. So what will happen? If you see, the left child of 3 is null. The right child of 3 is null. Similarly, the left child of 8 is null. The right child of 8 is null, means nothing. The left child of 13 is null. The right child of 13 is null. The left child of 11 is null. Okay. Now just see here. It has been mentioned whenever the pointer is null, it will return 0. So what this null will return to this 3? Its left child will return 0. What this null will return? It will also return 0. Now, whenever it is not null, then what it is returning? Its value plus whatever the value returned by the left and right part. So its value is 3. What the left part is returning? 0. What the right part is returning? 0. So 3 plus 0 plus 0 is 3. So it will return 3. Also, we have to focus one more thing. Before returning the value, it is printing the returned value, right? So this left child, and you have to see one more thing. Whenever the pointer is null, it is just returning the 0. It is not printing anything. So when it is returning the 0, it is just returning, not printing anything. When returning the 0, just returning, not printing anything. But in this case, when the pointer is not null, before returning, it is printing. So what it is printing? It will print 3. Similarly, this will return 0, and whenever it will return 0, it will not print anything. 0. Then what it will return? 8 plus 0 means 8. So before returning, it will print 8 and then it will return 8. Here you can see it is first printing the value, then only it is returning. Now, what this node will do? It will take 5 plus 3, 8 plus 8, 16. So first it will print 16 and then it will return 16. Okay. Now, this root node has got the value from the left part. Now it has to need the value from the right part. So this null will return 0, but because it returns 0, it will not print anything. It will also return 0. Now this is not null, this 13 node. So what it will do? 13 plus 0 plus 0, 13. So it will print 13 and then it will return 13. This will return 0. So 13 plus 0 plus 11 will print 24 and then will return 24. Now 24 plus 16, 40 plus 10, 50. So it will print 50 and then it will return 50. So this will be the output from the given code 3, 8, 16, 13, 24, 50. Let us see from the option 3, 8, 16, 13, 24, 50. You can see here this was the output. The correct answer will be option C. Okay. I hope now you have got the clear idea how to execute the recursion tree. So this is another question from data structure that has came in GATE 2023. So let us read the question properly. What it is saying, consider a sequence A of elements A naught equal to 1, A1 equal to 5, A2 equal to 7, A3 equal to 8, A4 equal to 9 and A5 equal to 2. The following operations are performed on a stack S and a queue Q, both of which are initially empty. Now what the first instruction is saying? It is saying that push the elements of A from A0 to A5 in that order into S. S is the stack. So suppose this is the stack. Okay. So in the stack, the first step is saying push the element from A0 to A5. So A0 is 1. So first we will push 1. Then we will push 5. Then we will push 7. then we will push 8 and then 9 and then 2. Okay, so 1 5 7 8 9 2. This is the stack S. Now the second step is saying enqueue the elements of A from A0 to A5 in that order into queue. So in the queue, the values in the queue will be 1 and then from A0 to A5. So 1, 5, 7, 8, 9, 2. Okay, the front part, and this is the rear end. We know that this is the queue. We know that in the stack always last in first out. The element which has came last will go out first, but in the queue the element which has came first will go out first, means first in first out. Okay, now just see the third step, pop an element from S. So whenever we will pop an element from stack, it will be the top element, not 2 will be popped out. Okay, so now 2 is not there in the stack. Let us remove the 2. So now 2 is not there in the stack. Now what the fourth step is saying? Dequeue an element from queue. It is saying that remove an element, delete an element from queue. Okay. So whenever we will delete an element from queue, it will be according to the first in, first out. So this is the first element that we will delete. Now it will point to here. Now let us see the fifth step. Pop an element from S. So when we will pop it from the top of the stack, so now this 9 will be removed, right? So let us remove it. So now this 9 has been removed. Now what is the next step? Dequeue an element from queue. Now we have to dequeue means we have to remove 5 from the queue, right? Let us remove 5. Now we have done the dequeue. Now this is the front element. Now the next step is dequeue an element from queue and push the same element into S. So when we will dequeue the element from the queue, what we will dequeue? The element that we will dequeue is 7, and we will push this element into stack S, and it will be dequeued from the queue. Let us remove it from the queue. Okay. Now this is the front position. Now it is saying that repeat operation 7 3 times, means first we have to remove 8, push into the stack, then 9, push into the stack, then 2 we have to push into the stack. So what it will look like? First we have to remove 8, 8 will come on the top, and then we will remove 9 from here, 9 will come here, and after that we will remove 2 and 2 will come at the top. Okay, so we have done this, and now the queue is empty. We don't have anything in the queue. The queue is empty. Now it is saying that pop an element from S. So we have to pop an element from S. So when we will pop, what it will do? It will remove 2. So 2 will be popped. Then it is again saying the 10th is pop an element from S. Again it will pop. 9 will be popped. So now all the steps have been performed, and it is asking that the top element of S, that is the stack, after executing the above operation. So we can see after executing the above operation, the top element of the stack is 8. So the answer will be 8. Okay. So I hope the complete execution of this is clear to all of you. This is the next question that has came in GATE 2023. This question is related to max heap. Let us read the question properly. Which one of the following sequences, when stored in an array at location A1 to A10, forms a max heap? It is asking that among the given options A, B, C and D, which is max heap and which is not max heap. Okay. So we know that what is max heap. In max heap, in every node, the value of the parent node should be greater than its children node. The value of the parent node should be greater than its children node. Okay. So let us one by one draw each of these heap and let us see which is satisfying the property of max heap. So each and every node should have a value greater than its child node. Okay. So let us first draw A heap. So it is 23, 17, 10, then 6, 13, then 14, and then 1, and then 5, 7 and 12. So in the order in which it has been written, we have to draw the heap. It is 5, then 7, and then 12. Okay. So if you see here, let us mark it as red. If you see here, this node 10. So what we know that in max heap, every node should have value greater than its child node, but 10 is not greater than 14. That's why, because of this 14, it is not satisfying the heap property. Similarly, if you see here, the 6 is not greater than 7. That's why, because of these two nodes 7 and 14, this tree is not satisfying the max heap property. So it is not max heap. Okay. So option A is wrong. Let us see the next one. Let us draw it. 23, 17, 14, 7, 13, 10, 1, 5, 6, 12. So here if you see, let us check for each node. The value of 23 is greater than 17, 14. Very good. 17 is greater than 7 and 13. Very good. 14 is greater than 10 and 1. Very good. 7 is greater than 5 and 6. 13 is greater than 12. So here if you can see that each and every node is satisfying the property of max heap. That's why the option B is max heap. Okay. Let us see the option C. Let us draw option C. 23, 17, 14, then 6, 13, 10, 1, 6, 13, 10, 1, then 5, 7, and 15. So here if you will see, you can see here also the 6 is not greater than 7. So because of this 7 there is an issue. Similarly, this 13 is not greater than 15. So this is also creating an issue. So that's why this is also option C is also not max heap, right? Let us see the option D. So it is 23, 14, 17, 1. Let's draw here. 23, 14, 17, 1, then 10, 13, 16, 10, 13, 16, and then 12, 7, 5, and then 12, 7, and 5, right? Here also if you see, this 1 is not greater than 12, right? So that's why because of this note 12, there is an issue. This 1 is not greater than 7. That's why this is also creating the issue. That's why this option D is also incorrect. So if you will see, only one option that is satisfying, that is option B is correct. Option B is max heap. It was asking which will form a max heap. Only option B will form the max heap. Option B is correct. This is the next question that has came in GATE 2023 exam from data structure. Just try to read and understand the question properly. Okay, first. Okay. So let us start reading the question. An algorithm has to store several keys generated by an adversary in a hash table. So there are various keys that we have to store in a hash table. Okay. The adversary is malicious who tries to maximize the number of collisions. Okay. Let k be the number of keys, n be the number of slots in the hash table, and k is greater than m, means the number of keys is greater than the number of slots. Now it is asking that which one of the following is the best hashing strategy to counteract the adversary. So we know that in a hash table there are suppose various slots. So when there will be less number of collision, when the keys will be properly distributed in the complete hash table. If many number of keys will go into a particular slot only, then it will create a lot of collisions. So we should always select that hashing strategy which distribute the keys in a proper manner. And we know that the universal hashing method distribute the keys in a uniform manner. That's why to counteract the adversary, we will use the universal hashing method. We will use universal hashing method to counteract the adversary so that less number of collisions will happen and the keys will be uniformly distributed in the hash table. So the correct answer will be option C. I hope now it's clear to all of you. This question has also came in the GATE 2023 part. Here, two functions are given, f and g are functions, where f of n is equal to n and g of n is equal to n square. Now it is asking that which of the following statement is or are true. The first statement is saying f is big O of g. What is the big O of g means? F is less than equal to c is some variable c into g. So let us see here, f of n is less than equal to c of n square. Yes, this is correct. N is less than equal to c. Let us take c as 1. So n will be less than equal to n square. Correct. So that's why option A is correct. Let's see the option B. Option B is saying f is greater than equal to g. F is greater than, f is big O of g na, so f is greater than equal to c times into g. C is some integer variable. Suppose c we can take as 1 or 2. So let us write n greater than equal to c of n square. This is not possible. So that's why this option B is wrong. Let us see the option C. Option C is saying f is small o of g. What is the meaning? F is less than c times g. So yes, n will be less than c times n square. Let us take c as 1. So n is less than n square. Right? So yes, this option is correct. Now it is saying option D, f is theta of g. What is the meaning of that? N is equal to c of n square. That is not correct. So that option D is wrong. So the correct options are option A and option C. Option A and option C are correct. I hope it's clear to all of you. What it is saying that let A be a priority queue for maintaining a set of elements. Suppose A is implemented using a max heap. Now we know that what is a max heap? We know that in a max heap, every node value is greater than its child value. The operation extract max extracts and deletes the maximum element from A. Okay. So what is the function of extract max? Suppose let us draw some random max heap. 100, suppose 90, E, T. Suppose it's a random max heap. Now extract max will extract and delete the maximum element from A. Okay, means whenever we will perform the extract max on this max heap, it should return 100, and also it's whenever it will delete an element, after that, after deleting that element, the resulting heap should also be a max heap. Similarly, the insert A comma key inserts a new element key in A. The properties of max heap are preserved. Focus on this keyword, are preserved at the end of each of these operations. Now it is asking that when A contains n elements, suppose there are n elements in max heap, which one of the following statements about the worst case running time of these two operations is true? So whenever you delete any element, how you will do that? Simply, what you will do? You will take the last element 60 and you will just copy the value of the element 60 to this node 100. So now the 100 will be deleted and here 60 will be copied and this link will be deleted. This node will be deleted. But now you can see here, this is not a max heap. Extract max will be completed when you will convert also it into a max heap. You can see that both 90 and 80 is greater than 60, but which value is greater? 90. So here 90 will come and here 60 will come. Again 70 is greater than 60. So now 70 will come and 60 will come. So after performing extract max, the 100 will be returned, 100 will be deleted, and the resulting heap will be 90, 70, 80 and 60. You can see this is the max heap. Now you can see here, whenever we have copied the value from the last node to the root node, after that we have to adjust, and for adjusting how much time we can need, here you can see at every level we have done the shift. So max at max, at every level we have to do the shift. So if there are n nodes, how many levels will be there? Log n base 2. So that's why the extract max in worst case will require log of n time. Okay. Now let us see for the insert operation. So how do we do the insert operation? Suppose we have to insert 200. So first what we will do, simply we will simply at the end we will add 200. But here we can see it is not max heap. So now we have to convert it into a max heap. So we will see 70 is less than 200. So 70 will come here and 200 will go there. And again if you will see 90 is less than 200. So 90 will come here and 200 will go upwards. Okay, so you can see after the insertion of 200, the resulting max heap is 200. Here it is 90. Here it is 80. Here it is 60, and here it is 70, which is a max heap. Here also you can see that after inserting the element, you have to perform the adjustment, and for the adjustment it will require also log n time. So that's why both extract max and insert operation will require in the worst case order of log n time. That's why option B is correct. Both extract max and insert operation will run in order of log n time in worst case. Okay, so option B is correct. I hope this concept is clear now. In GATE 2023 from programming and data structure, so what has been given? Consider functions, function 1 and function 2 expressed in pseudocode as follows. Okay. Now it has been given that let f1 and f2 denote the number of times the statement x equal to x plus 1 is executed in function 1 and function 2 respectively. So let us see how many times this statement is executed in function 1. What it is doing, you can see there are two loops. One is while loop, the outer loop is while loop, and the inner loop is for loop. So while n is greater than 1, do for x equal to 1 to n, means first n times this statement x equal to x plus 1 will be executed. Then after that it will come out of the for loop and n value will be changed from n to n by 2. After that again the for value will execute from 1 to n by 2, because now the n value has changed to n by 2. So now it will execute n by 2. Again n by 2 will change to n by 2 divided by 2, means n by 4, and then it will execute for n by 4 times, and similarly it will go on. So total how many times it will be executed? Let us see. N plus n upon 2 plus n upon 4 plus n upon 8 will go on. Let us take n as common. It will be 1 plus 1 upon 2 plus 1 upon 4 plus 1 upon 8 will go on. If you can see that this is a GP, right? The sum of infinite terms of GP, where R is 1 upon 2, the common ratio, right? And we know that the sum of infinite terms in GP is A upon 1 minus R. So what we can write, n into 1 upon 1 minus 1 upon 2. So it will become 1 minus 1 upon 2, it will be 1 upon 2, it will become 2n, right? So this function f1 of n we can write as, it is how many times it has executed? 2n, right? Now what about this function 2? For x equal to 1 to 100n, do x equal to x plus 1. So how many times it is executing? Simply the function 2 is executing 100n times. f2 of n is executing 100n times. So f2 of n is 100n. Okay, so let us see the option. F1, let us write it here. F1 of n is 2n and f2 of n is 100n. So it is saying which of the following statement is the R true? Generally, we can write it as theta of n. We can also write it as theta of n because 2 and 100 is constant. So f1 of n is equal to theta of f2 of n. This option is correct. Whether f1 of n is strictly less than f2 of n? No, both are equal. Asymptotically, both are equal. They are not less than. So that's option B is incorrect. Option C is saying f1n is strictly greater than f2 of n. No, it is not strictly greater than. Option D is saying f1 of n is less than equal to c times of here f2 of n. Here f2 of n is missing. Here it is f2 of n. Yes, because here it is equal to sign. That's why this option is also correct. So that's why options A and option D both are correct. Okay. I hope this question solution is now clear to all of you.